Hello class, this lesson we're going to learn about properties of centroids. And before we can talk about centroids, we have to talk about medians. Now a median is a special segment inside a triangle, and it connects a vertex to the midpoint of the opposite side, so the side that doesn't touch it. So for example, BD is a median here. And we can draw three medians in any triangle. And it turns out that they are concurrent, so they all cross at a single point. And the name of that point is the centroid. So in this example, that would be point P. Now there's a special property of the centroid. The centroid cuts the median in a way that the distance from the vertex to the centroid is always twice the distance from the centroid to the midpoint on the opposite side. So the idea here is that we want to find a point, I'll call it G here, so that we can cut this median into thirds. And then these 2/3 over here, that'll be double this piece over here, at 1/3. So that's what we want to get at. And to prove it, we're going to apply properties of midsegments, like we learned in the previous lesson. So the objective here is we have this parallelogram, and we want to show that the medians are concurrent, so they meet at a single point. And to do that, we have to prove that property that we just learned about. So the idea is we have this parallelogram here, and it's made so that H is the midpoint of AG, and J is the midpoint of GC. And so if we can show that these cut it into thirds, then we have that first property proved, and then we can show that they're concurrent. And so we want to show we have a parallelogram because we know that the parallelogram will, the diagonals in there will bisect each other. So here is our parallelogram drawn. We drew the median from A to E, from C to D. And to make the parallelogram, we found the midpoints here. So that's AH, that's congruent to HG, and GJ, congruent to JC. So why can we say that segment DE is parallel to segment AC? Well, these are all midpoints by what they gave us. So you know that since that's a midsegment, those have to be parallel. We proved that in the previous lesson. So we have these are parallel, and we want to show that DE is parallel to HJ. So how can we get there? Well, you know HJ is parallel to AC. Why is that true? Well, we drew midpoints here, so we have a midsegment. So we know that that's going to be parallel to the opposite side. And so then why is DE parallel to HJ? Well, we proved that in a previous lesson. If you have two segments parallel to the same one, then the original two are parallel. So you can draw a little chevron on here. And there we go. And next we claim that DE is half of AC, and HJ is also half of AC. Why is that true? Well, these are both midsegments. DE is a midsegment in triangle ABC, and HJ is a midsegment in triangle AGC. And so since those are both equal to the same thing, DE equals HJ by substitution. So these are congruent. So do we have a parallelogram? Yes, we do. And why is that? A pair of opposite sides are both congruent and parallel. So therefore, you know that HG equals EG and JG equals DG. Why is that true? Because diagonals in a parallelogram bisect each other. That's what we wanted. So now we can say AH equals HG. Oh, I'm sorry, we already had that. That's from how we made our midpoints, right? And now we can say that all three pieces here are equal in length. And why is that true? That's substitution. Right, we said AH equals HG, and HG equals GE, so put it all together and we get these equations. And so now we prove that claim that we said before. The distance from the vertex to the centroid is twice the distance from the centroid to the midpoint on the opposite side. And that is just by the partition property, or segment addition. And a little bit more work there if you want to see it. AG is really AH plus HG, and you know each of these two pieces is the same as GE. So it's really just 2GE. And you can repeat this for the third median from B to F, and you'll find that it cuts it the exact same way. And so the intersection point, the G, is going to divide each median into those two parts with the same ratio, so all the medians have to be concurrent at that point. So if we were to draw in BF, and you look at BF and AE, if these intersect at a point that's not G, then you know that you won't have that special property saying that AG is twice GE, because if it's not G, then it can't hold. G is the only point that will satisfy that. So there's a bit more to the proof, but that's the overview of it. So this is a recap of what we said. And so you have the center of gravity there, the centroid, and it divides these segments like we wanted them to. And so let's apply that property. So we already saw that we can say BP is twice PF, and we can write two other useful equations. Let's see if we can relate, let's see, BP to BF. I'm going to put that one last, actually. So if we know that we have some point here that will cut this into thirds, then what's the relationship between BP and BF? Well, BP must be 2/3 of BF. And what's the relationship between PF and BF? So the piece from the vertex to the midpoint. Well, since it's cut into thirds, if you triple PF, you must get BF. And you can either multiply or divide both sides of these equations by those constants to get equivalent equations that might be more useful in other respects. So for example, in this last one, you could multiply by 3/2. All right, multiply by the reciprocal, so you get 3/2 BP is BF. But these are the three basic ones you need to know. So now let's apply them. So try this on your own, and then I'll show you my answers. So you can figure out what all of the 6 measurements are here. So here are my solutions, and let's look at the work to get them. So FC, that's from the vertex to the centroid. So it's going to be double DF. They give us DF up here. So you might want to write those in on your diagram to help you out. DC, that's this whole median. And we know that's going to be 3 times the distance from the centroid to the midpoint. And AF, that's 2/3 of the entire median, AG. Now, for some of these, there's more than one way to do it. You can add together pieces you already know, for example, to find the median length. But sometimes it's easier to just do it with one equation. Let's see, BE, that is the distance from, that's this whole median here. And they give us BF. And so if we multiply by the reciprocal, instead of using the 2/3, you're going to have the whole median is 3/2 of that distance. And we get similar equations for E and F. Here's an algebraic application. So the most important step is the first one, writing down that equation that relates these two quantities. So if we're looking at OL and OQ, how are they related to each other? Well, OL is the distance from the vertex to the centroid. So you know that's 2/3 of the length of the median. So I wrote my equation like this. OL is 2/3 of OQ. And now it's just algebra. Substitute for OL and OQ. And this works out nicely if you distribute instead of trying to do, I mean, you could do it other ways, but I think distributing is nice because you have that 3 that you're dividing by, and these are both factors or multiples of 3, right? And solve this, subtract 6x from both sides, divide by 2, and we get x equals 2. In this lesson, we learned how to prove and apply properties of centroids. Thanks for watching this video.